Sir, I think we can start. I have texted in the group. If anyone wants, they can join it later.
Okay, fine. So this is the final setup that we left not yesterday, maybe day before yesterday, or maybe even the last class. So I don't want to discuss again the meshing and everything, as you already, I believe that you already learned up to this meshing part. If you still have any queries, I will give you 1 minute to quickly answer your question, to quickly give your question so that I can answer it. Any questions so far up to meshing? If not, we can proceed further. So then quickly raise your hand if you're all done with the meshing part. Meshing part and name selections also. Mohammed, okay. Aman, okay. Shayak, right? Please raise and hold your hand. Like I will just count it so that only 1, 2, 3. Triangle 4, 5. Okay. Fine. Good. So down your hands. Thank you all. Good. Thank you all. So if you all are okay with the meshing part, then we discussed something yesterday that can someone tell me that what are the dimensions that we decided? What is the diameter Reynolds number 20 that we decided yesterday? You can also text if your microphone has any issue. You can text here. We decided some dimensions and some velocity yesterday based upon the Reynolds number of 2000. It's not 2000, maybe 20 and 50, I believe. Can someone quickly send those details? Others, please down your hands.
Sir, let me check. I will tell you.
They all are there in the lab or at different locations?
No, they are in the lab only. I am joining the meeting from my room.
They are all in the lab.
Yes.
Okay. You are not guiding them, they may feel like they're missing Arhit, right?
Yes, sir.
If you are not guiding them personally, they may feel like Arhit is not here and they miss you there in the lab,
Yes, sir.
isn't it?
Yes, sir.
You are the expert.
No, sir, it's not like that.
Fine. So, who are all in the lab now, right now, like sitting at the same place? Many of you are in the lab now.
Ajay, uh, Nizam, Nizam.
Yes.
Yes, sir. Who are there in the lab? Mohit is also not here in the meeting.
I am at my home.
So everyone is doing from home.
Yes, sir.
Who are all there in the lab, Nijam? Like, can you just raise your hand if you are in the lab? If you all are in the lab, whoever available in the lab, can you please just raise your hand? Here it is. No one in the lab. Okay. let's start the today's session. I'm still waiting for your comments, like what are the dimensions yesterday that, okay, Arihima and Nizam is at home. Fine. Let's start the session instead of worrying about the details. Please send me the details of diameter, Reynolds number for Reynolds number 20, and
Yes, sir.
fluid details and the diameter, velocity. What are the details we discussed yesterday? Can you please, someone quickly send the details
Yes,
except
sir.
Arihit?
Yes, sir. Sir, Reynolds number is 20.
Except Arihit, can someone please send those details? Arihit, I know you can do it. Let me give a chance to others.
Oh, okay, sir.
Anyone can please send the details. You have the option question and answer. There you can type and let me know the things. And if you delay it, it will be delayed. Anyone, I will ask them. If no, not someone. Aman, can you quickly send the details?
Yes, sir. I am sending to you, sir.
Yeah. So in the meantime, everyone open your answers workbench and open your geometry. We are going to do some modifications according to the dimensions and things that we did yesterday. So open your design modeler and let's try to edit the geometry that we already prepared yesterday.
Hello.
Yes, sir.
Very good afternoon, sir.
Good afternoon, sir.
Actually, today I am out of station and there is facing the bad network. But I am trying
Okay,
to listen you carefully, and after that I will watch the recording video.
Sure, sir. Sure. It is up to our convenience, everyone convenience. So I have proceed with your.
I'm in the class and I'm trying to listen you carefully.
Sure, sir. Okay.
Oh, thank you, sir.
So right now we are going to edit our sketch. If you all having this geometry ready, so listen this one carefully. Now we are going to edit our geometry with the dimensions. So no, Aman, I'm not asking about these dimensions. Yesterday we discussed what should be the velocity, what should be the diameter of the cylinder for a Reynolds number of 20 and Reynolds number of 50.
Okay, sir.
Were you there in the yesterday's class?
Yes, sir.
Yeah, I want those details.
Okay, sir.
I believe it may be 0.002, 0.02 or 0.002. Yesterday, someone told me that radius is how much? Radius or diameter? Pranjal? I remember that you told some answer yesterday. It's 0.022. How much it is? The radius of the diameter is 0.002.
Sir, maybe velocity was 0.005.
Velocity is 0.005. That's right, sir. But we changed the diameter also for that 0.005.
Yeah. It was maybe 2 meter.
2 meter is quite high, sir. I feel. Very less value I said yesterday. Let me check it once again if they don't have the notes. Yeah, diameter is 0.01 that we are fixing and velocity is 0.002. This is the diameter and velocity. So 0.01. So everyone change your diameter to 0.01 in your geometry like the way I'm doing now. And also correspondingly, you can do the remaining things. So now you see, I changed my diameter and clicked on the generate button. Here is the generate button you can see. So once again, I will do it for you. So click on the sketch for this one. If you have this kind of tree, you should click on the plus button here. There is a plus option. Then only you will get the sketch icon like this. So go to the sketch and edit it. Edit it means again you need to go back to the sketching option. Okay. Then go to the dimension. Suppose if it is R11, so go to your dimension. And if you're saying already if you have 1 meter of radius, then fix it to 1 meter. Click to generate. Come back to the modeling and click on the generate button. Just give me a second. It's not getting updated. Okay, last dimension we choose as a 10 meter. So if you have, you might be already having a 10 meter as the radius. So now our target is to set this 10 meter to only 0.01 meter. Okay, so to change that, click on the radius and select it as 0.01 as the radius or the diameter. Carefully look at the details. The details, if we see, the diameter is 0.01 meter. That means the radius is half of it. So it should be 0.005 meter as we are setting the radius. Fine, right. Then click on the click on the generate option. Okay, you see now the circle is very small because we set the radius as 0.005. And so correspondingly, we need to change the other dimensions also. So I will change the horizontal 350 to say 1 meter. 1 meter would be so small. And H10 also 0.01 meter, not 0.02 meter. And then H6 also 0.2 meter. Okay, now these are looking reasonable. So adjust your dimensions in such a way that these are the dimensions, that is h10. The distance between this left corner to the center is 0.1 meter, and h6 is the length of the horizontal base, that is 0.5 meter, and the radius of the cylinder is 0.005 meter, and the vertical distance from this point to this point 0.1 meter, and V9, the remaining distance is 0.1 meter. So do you need time to do this on your end? Shall I wait for some time? You can do it on your own right now, or you can do it later on. What is your preference? Can someone answer this? Aman, would you like to do it now itself at your end, or?
Yes, sir. Yes, sir. Wait for a minute, sir. I give the
Okay.
dimension to it.
Yes, very good. So dimension you apply in such a way that the radius is 0.005 meter, and h6, that is total horizontal distance from left corner to the right corner of the rectangle as 0.5 meter, and h10 between the left corner to the center of the cylinder as 0.1 meter. If you're done with the dimensions, then you can quickly. Okay, Mohammed is saying later on. Fine, Aman, you can do it on your own, right? I believe you can do this.
Yes, sir. Yes,
Okay.
sir.
So let's listen the final version of the simulation. So after the completion of this geometry, you have to get this kind of dimensions, and this is the geometry view. Then click on the generate button. There is a generate option here, so click on that. Once you've done the generate option, it will automatically update your model. Then you can close your design modeler. So after closing the design modeler, now you can go to the mesh, click on the mesh, and right click and go to the edit option. Okay, because now we also need to set the mesh correctly, or we need to check whether the mesh previously generated mesh is updated or not. So if you want to check whether it is correct or not, then right click on the mesh and click on the update or start meshing or edit meshing. Then your meshing screen will open again. So you see, this is the model that we generated last time. Now it will change to the model that we generated at this point of time. So you can see the mesh is not yet generated. If the mesh is not generated, you can go to this generate option and click on generate. Once you click on generate option, it will show you the details. Can you see there is a very small, very small geometry showing in the meshing graphics window. If you want to zoom it clearly, you can use your mouse button. Like click on your left, or sorry, click on your right mouse button and drag the area. Hold click, right click and hold and drag the area. Right click and hold, drag the area. Now you can see my cells are too big in such a way that I gave a cell size as 2.5 meter in the last um sorry in the last geometry. So respecting that condition, it completely failed to create the cells correctly as per the requirement. It is completely a failed mesh. This mesh is not correct for our simulation. So what should we do? We need to decrease the cell size. Last time we have the cell size of because the diameter of the cylinder last time was 10 meter or 5 meter as the radius. We gave 2.5 meter as a cell size. Now what we need to do is you go to the click on the mesh and go to the element size option here. And the element size option, give the half of your diameter, half of your radius. If the radius is 0.005, let's set 0.0025 as the cell size. Okay. Once you set that, then click on the generate option again. It will generate the mesh now. You can see there is a 5% of meshing is done. So let's wait for the remaining process. You won't see this window. If you want to see this window, you can click on here. Here there is a meshing option, right? There you need to click on it. Then it will show. If you give your dimension very small in such a way that it sometimes occupies entire your memory and it may hang also. You should give the size appropriately such that the number of cells are also sufficient, or you can run it can run the simulation. Now you can see the same mesh that we generated last time appeared here. Okay, so I believe everyone can do this step also after changing the geometry. Yeah. So if you want to see how many number of cells are there in this blocks, I mean how many number of cells means how many number of blocks or small blocks are there in this geometry, you can just go to the statistics option here at the bottom, left bottom. There is a statistics option. So you can click on the statistics option and you can see number of elements, not number of nodes. Number of elements are 16,106 cells are appeared in this mesh. Okay. Now how many of you are clear with this step? If yes, can you please raise your hand? Mohammed is all right. Aman is all right. Others, can you quickly raise your hand? These steps are all familiar to you. I just revising it. Manju sir, fine. Okay. Sayak, Pranjal, Arhit. Arhit, you know it already, I guess. Yeah. What about Sayak? Already fine. Okay. Very good. Thank you. So this is the process to regenerate the mesh after changing your dimensions. Okay, please down your hand. So if it is done, you just click the generate button for generating the mesh and then go to the mesh and right click and click on update. If you click on this update, it will transfer your mesh to the Fluent module. You can see the information here. The information is the mesh translation to the Fluent was successful. You should get this message. If not this message, that means you still need to update your mesh. If you want to update your mesh, go to this option, right click and click on the update button. Then you will get the message like the mesh translation to Fluent was successful. So Aman, do you have any questions? Okay. If that is done, then you can close your mesh. Now we are ready to set up a simulation. Okay, how to set up the simulation? What are the conditions that we need to give for the software? So click on the setup button and right click and go to the edit option. Okay, I have already discussed a few settings here at the beginning with the beginning lectures, how to handle this startup window of your Fluent launcher. Let me open the Fluent launcher once again for you. So click on left click and then right click and click on edit option. Okay, then what we need to do, we have to select the double precision. Okay, it automatically select based upon your geometry because our geometry is 2D, so it is already selected the 2D option. Then no need to select any other things, double precision and display mesh after the reading. Then you can go to the number of solver processors and number of GPUs per machine. Okay, so other options are not necessary for you to start. So only you need to find out how many solver processors are there, how many solver GPUs are there in your machine. So how to find out these things? If you don't know how to find out these things, you cannot enter the details here. And doing the simulation without understanding these things is very like waste of time and resources also. So to carefully understand what are the number of solver processors and solver GPUs per machine, go to the task manager, start and go to the task manager. And there you can find performance tab and go to your CPU. For the CPU, you can see I have logical process. So Fluent can work with the logical process. So I have a logical process of 12. I don't want to use my entire logical process 12, so I use only up to 10. I leave two logical process for other system details, other programs, and then how many GPUs you want to set up. So if you have any GPUs other than GPU 0, GPU 0 is common for everyone. In every system, GPU 0 is common. It handles your basic graphics purpose. If you have any other GPU, that is GPU 1, NVIDIA GPUs or other company GPUs, if you have, you can set the number of GPUs as 1. Okay. If you don't have any GPUs, don't touch it. Keep that as 0 as it is. Okay. So right now I'm keeping as 0. I'm not using my GPU, though I have a GPU. And then click, and then now you set. So 10 and 0. Is this process clear? Aman, you have any doubt?
Sir, if I have a GPU, so How can I put the values, sir?
How many GPUs you have? If you have two GPUs, generally one GPU is common, so you can put one.
Okay, sir.
Mohammed, you have any
How
doubt?
you
I think
consider? Yes, sir. How you consider solver process is 10?
solver processes, you see, open your task manager and then go to the performance tab here. Okay. After going to the performance tab, you have a CPU tab. This is the information of your CPU. So go to the CPU information. In the CPU information, if you see at the bottom, uh, at this bottom, you can see cores are 6 and logical processors are 12. So Fluent works also,
Yes,
Fluent
sir.
can work with the logical processors. So maximum logical process you can use in your system is 12. So in my system is 12. If you have more, you can use more. Okay. So I don't want to
Okay,
use
sir.
all my logical process. I want to keep 2 idle because I don't want to load entire system. So I'm keeping my 2 logical process idle and remaining 10 I want to run use for the system. Okay. That's it. Any more doubts? Okay, if no doubts, let's proceed for the next step. So that is done, then you can click on the start button. So this is very, very important step. You should remember every time how to set up your Fluent startup launcher. If you don't know this, you will not able to use your system resources perfectly or effectively, I can say. So it will take some time to start your Fluent system. It will automatically load the mesh and every details. And I hope you all remember how to, like, what are the named conditions that we gave in already in the mesh. So if that is the case, then we can proceed it further easily. So if you all having latest version, maybe 2022 or 2023 or student version, whatever, it has a very good graphics capability and a good interface also compared to earlier versions. So now you can see the arrow directions. What are the arrow directions it is showing here? That is considered as the inlet of the flow. That means flow or fluid enters into that particular edge, enters from that particular edge, and then exit through the outside arrow. You see the outside arrows are normal, so it is reasonable to see these kind of things. But you have a question already that I answered yesterday. Sir, you have given already these edges, the top edge and bottom edge also inlet. So fluid is coming in this way, I mean, towards in the y direction upward. Fluid is also coming in the upward direction. So no, because we have an option in the fluid to set x direction or y direction fluid velocity. Let me show the triad. Do we have triad option here? Axis triad, yes. Just give me a second. Okay. Anyway, it is not show. It is not visible here. The axis triad. So assume the x-axis is horizontal and y-axis is vertical. So if your x-axis is horizontal, I can set in my fluid such a way that only allow the fluid in x direction. Do not allow the fluid in y direction. That means fluid won't come in the y direction. Though the arrows are showing here, the fluid won't pass through this particular edge and enter in the y direction. It can only flow in the x direction. So that condition I'm going to set. That's why it is not an issue even if you select this edge as an inlet. All right. Okay. So let's go to the settings of this Fluent. So all the required settings to run the simulation, this Fluent user interface already available in the left side page that you are seeing here. That is outline view. So do not worry about the top view. So we don't need to worry about that. We only look at the left side, when this left side outline view, the settings here are sufficient for the simulations. So how to start with? So these settings, you just note it down one by one. Every setting you just need to note it down, and if you want to understand all these settings, I will give you the basic understanding of what are those settings now. So in the general tab, we have an opportunity to set what kind of solver we are going to use. Solvers means we have already discussed, there are Navier-Stokes equations, those things we need to solve. So there are methods, we cannot use different methods. For solving those particular equations, we have two type of methods. One is pressure based and density based. Even these methods are depends on what kind of flow also we are solving. It is dependent on what kind of flow we are solving. So let's take it as granted that we are now solving with the pressure based. Okay, so pressure based generally used when your density is constant. You say if your density is constant, why you are saying our density is constant? We are using the fluid as water, and its speed is also very low. We can say it is 0.02 something that we calculated yesterday. So that means our density is constant in the flow field. So that's why we are making it pressure based. If your density is also variable, then you may need to use the density based solvers. Okay. All right. So let's use the pressure based, and velocity formulation as absolute. Do not need to change that. And the time, whether we are solving the variables, whether we are solving for the flow field at every time instant. If you want the solution of pressure, velocity at every time step, then select transient. That means you will get the solution at 0.001, 0.002, or whatever the time step that you gave, and how long you want to simulate. So at every time instant, you will get the information of flow field, pressure, velocity, and every details. So that's why I'm selecting the transient. So I don't want to use the gravity here. So let's not select the gravity. Then let's go to the models. If you expand this button, expand the models button, and then click on the viscous SST here. It is the default is viscous SST, but we are solving only the laminar region. We don't want to go for any other region. So click on the laminar here. So how to open this window? Expand the models tab. This is the models tab. Expand this and click on the viscous. Double click on it. Okay. After clicking on that, you just go to the laminar. Select the laminar. Do not select anything. We don't want any other models. So laminar model and click OK. Done. Fine. Now we yesterday decided to use a material as water, not any other material. So first we need to see what is the default material in the ANSYS Fluent. So the default material for the fluid is air. You can see if you expand this materials tab and you expand this fluids tab, fluids tree, then you can find the material as air. So we need to replace this air. So right click and go to the new button. Right click on the fluid and go to the new button. There you have an opportunity to select user defined database or Fluent database. So in the Fluent database, let's check whether we have water as a medium or not. So I'm going to Fluent database, and I will see for the W. Yes, in the W letter, I have a material water liquid H2O. So I will select this and I will copy it and close. Okay. So now we have the water liquid H2O, 998.2 is the density and 0.001 as a viscosity. This step, is it clear for everyone, or shall I repeat it once again? How many of you want me to repeat it once again? Okay, one. This particular step, how many of you want me to repeat again? Two. Okay, Sayak. Okay, two, three. Others, please raise your hand. Please raise your hand and hold there. If you don't understand, I will repeat it once again. Okay, Pranjal. Okay, fine. So I believe you did not get this step. So this step, I will repeat it once again for you. So we are decided already to use the material as a fluid as a water. That means the fluid passing in this domain, whatever this computational domain, the fluid should be water. It should not be air. But the Fluent ANSYS Fluent software has a default water as a medium. So to change that, go to this material option. There is a materials tab here. Click on that. Okay, and after that you go to the Fluent. This is the fluid. Okay, right click on it and go to the new fluid. So here it is creating some fluid, but we don't want to use this fluid. Fluent database already have water readily in that. Database has it, but it is not applied to the our domain. So to load from the database, to load the water properties from the database, go to the Fluent database, and then here is a window, sliding window you can see, and here search for a water liquid H2O. Okay, then click on water liquid H2O and then copy that. After clicking on it, you can just copy that, copy it and close. Now you can see the fluid is water liquid H2O and the density is approximately 1000 kg per meter cube and viscosity is 1/1000 kg per meter second. Okay. Okay, right. This is the step that you need to remember all the time to load the fluid as a liquid water. Is this clear now? If you understood, just raise a hand. If not, I will. You can repeat it. We can discuss it once again later. How many of you understood this step? Just please raise your hand. Yeah. Now I believe everyone got this step. Very good. So now we just loaded water liquid into the Fluent data from the Fluent database. So let's apply this water liquid to this domain. Whatever the domain we created, there we need to apply this water liquid. So close it. So how to apply that? How do we apply that? So if you want to apply that, go to the cell zone conditions. The next one, expand the cell zone conditions and expand the fluid tab. You will see there is a body with surface body with fluid ID2. So there you need to double click and change the material name. You see the default is material air. There you need to change from air to water liquid. Okay, change to air to water liquid and select apply. Okay, now it is applied. You see now the surface body means this is the computational domain that we named as the surface body. The default it automatically names. So that we need to change from air to water liquid. Okay, and then apply. Then close it. So now our domain is applied with water. If you want, if you want to delete the other fluids, you can go there, this particular option, and delete the other fluids because we want only water. We don't want any other fluid. So we just deleted the remaining two fluids. Got it? Okay. If you want to delete the water liquid also, it is not possible. Now you can see the delete option is not appearing because you just applied the water liquid as a medium in this domain, in this cells. Okay. Yes. Then next step is boundary conditions. So in this boundary conditions, you just need to expand this boundary condition and then we need to set up all the conditions respectively. What is our inlet velocity condition? Can someone quickly text me or tell me what is the velocity for Reynolds number 20? If I expand the inlet boundary condition, it is the boundary conditions and expand the inlet and then double click on this velocity inlet. You need to double click on it. Mohammed is saying, sir, can you take water density as 1000? Why not? You can take. No issue, Mohammed. Okay, you want me to ask, you are asking me to change the water density to 1000?
Yes, sir.
Okay, I can change. That's not an issue. So if you want to change the water density to 1000, here go to the fluid and change the water liquid and then apply it as 1000. Change or create. That's it. So now you see my water density as 1000. Okay.
Yes, sir.
So then now we need to set our inlet boundary condition. The boundary condition is inlet that we need to set the velocity. So to set that velocity, double click on the velocity inlet option. So there you need to choose velocity specification method. I want magnitude and direction. not the components. I want to set the magnitude of my velocity and which direction it should flow. So I choose a magnitude and direction option, and reference frame is absolute reference frame, and velocity magnitude. What is the velocity value for Reynolds number 20? So Arhit is saying it is 0.002. Can someone others also please confirm that? So velocity I'm setting as 0.002. So you don't need to change anything here, the supersonic initial gauge pressure. And then X component flow velocity direction. That means here you can observe that X component flow velocity direction. I told you that X is horizontal flow. That means it allows the flow in the only horizontal direction. So that I set as 1. Y component flow direction. If you set this one also 1, then it will allow the flow in X and Y directions both. Yeah, since I set this as component as 0, it now only allows X flow in the X direction, that is in the horizontal direction. So now this step is clear, everyone? If yes, just raise your hand if this step is clear or not. Okay, Mohammed understood this step. Others? Okay, Ajoy, Syed, fine. Ranjal, fine. Good. So then, if that is clear, Aman, okay, yeah, place down your hand then. So click on the apply button and click on close. We just set our velocity inlet condition. Then internal, we don't need to worry about that. Internal is the default condition. Then come to the outlet. Outlet we already defined as a pressure outlet. So double click on the pressure outlet. You see all are already default. Nothing you need to change here. We are setting already the absolute gauge pressure. Gauge pressure means, how many of you know what is a gauge pressure? How many of you know what is a gauge pressure?
Sir, different between absolute and surrounding pressure.
Yes. So if my gauge pressure is 0, then I'm setting it outlet also same pressure, right? Atmospheric pressure. So I'm setting my gauge pressure is 0. That means my outlet pressure is atmospheric pressure. And then pressure profile multiplier that we need to worry. I don't need to worry about it. And the direction, all other options are not relevant not relevant to us for right now. Okay. Then click apply and close it. So wall condition. Let's see whether wall condition is clearly applied or not. Right click and edit. So what is wall condition? Can someone tell me where we applied this wall condition? Can someone quickly tell me where we applied this wall condition?
At the center, the circle of, at the circle, sir. At that
At the
point,
surface of a cylinder, yes. So to the
surface
cylinder
of
we
the cylinder.
applied,
Yes, sir.
yes, to the surface of the cylinder we applied the wall condition. That means we are saying to the software that is a wall. You should not allow the fluid to pass through that. Okay, so that's why we are setting as the wall condition. So you can apply and close it. So all the different operations and options for other types of simulations that we are not doing right now. So next what we need is we need the reference values here. So click on the reference values, double click on it, and then select this compute from. Select this compute from option to drop down from the drop down and choose the velocity inlet option here. This option, compute from, and choose the velocity inlet option. Okay. So there we need to select our values correctly. So what is the reference area? Reference area is something like, if you see a cylinder from the top or a shaft, if I see this is your cylinder, assume this is your cylinder, and if you are seeing from the top, what is the area that you are going to see? You are going to see the diameter times the length, right? The plane form area that you're going to see. So the diameter times and the length of the cylinder. So here since it is a two-dimensional one, what should be the area? Two-dimensional means that unit, it we considering this normal direction length is unit. So the diameter times the unit length. So what is the value of the area? Aman, what is the value of the area?
Value is diameter is 0.
0. The diameter is 0.01 and the length is unit length. So 0.01 into 1 is 0.01 meter square. Yes, L into D. Right, Mohammed. And the density is 1000. It automatically loaded because we already given the condition as 1000. And the depth is 1. Depth is nothing but the normal direction because we are doing a two-dimensional simulation. The depth is unit depth. Okay. And there is no enthalpy we are giving here. And the length is diameter. The length is diameter here. This is a characteristic length. So give the diameter as 0.05. Sorry, 0.01. Okay. So that is your diameter as a characteristic length 0.01. Pressure, we are giving a gauge pressure. So no need to give any value for the pressure. Temperature is also default. So this temperature will be maintained in the entire simulation. And the velocity we already given at the beginning, that is 0.002. And the viscosity also we maintained, right? We already given at the beginning. So ratio of specific heats. Everyone is clear about this ratio of specific heats, I guess. I don't need to explain what is this ratio of specific heats. You all are well known with the thermodynamics, right? And then additional heat transfer coefficient conduction. We are not dealing with any thing with respect to the heat transfer. So leave this term also as a default. So now we just set the reference values also. So this is done right now. So then go to the methods. All these options are right now not necessary. Then go to the methods option. Here you can choose from simple to the coupled. Okay, from simple to the coupled, and remaining all we can leave as a default. Nothing we need to change. Okay, just change the pressure velocity coupling and the scheme to the simple to coupled. Okay, this scheme you change to the coupled. Yes, Arhit.
Sir, that ratio of specific heats is Cp by Cv, that is gamma, what we select for air or water.
Exactly. Yes.
Okay.
Yeah. So here in the pressure velocity coupling, we just select the coupled scheme. Then go to the controls option. Here, set your flow current number to 1. Nothing to change. Nothing else to change. Set your flow current number 1. Okay. And then remaining details, we will see it later on how to use the remaining details. So, but for one particular interesting thing that you may be interested to see, go to this. I will show you that advanced things, how to monitor the forces and how to monitor the other parameters later on. So first let's run the calculation. So to run the calculation, you need to initialize the solution. That means you need to give some initial conditions kind of thing. So give the initial conditions from the initialization. So here at t star equals to 0 or t equals to 0, you need to give your conditions. So click on the initialization, double click on it and click on hybrid initialization and then initialize. So this will initialize your solution. Okay, fine. So to see the result at this t star equals to 0, that means it just initiated your solution. That means you have the information at time step 0 seconds. You don't have the information now at other time steps. At other time steps, your solver will now compute the information or the results at other time steps. We just initiated such that we got some results. So if you want to see those results, go to the graphics here and then click on contours and then deselect all. Static pressure is fine and then save and display. Now you see this is how we initiated. That means all the cells here in the domain, this is our domain, all the cells are having a same pressure value. That's how we initiated. That is a time step t star, time step t equals to 0, t equals to 0 seconds. This is the condition. So at later time steps, by solving your solution, you will get the details of pressure and velocity and how it is distributing in the flow. Let's see the velocity also. So you can see it is the expectation, that just an expectation that this is how the velocity looks like at the time step t equals to 0. But if you want to get the time at other relative seconds, other seconds at t star equals to, sorry, not at time t equals to 1 second or t second, you need to run your simulation. Okay, so how do you run your simulation? Let's see, let's run the simulation. So go to the run calculation here, click on the run calculation and set the number of time steps as say 100 and time interval size as 0.00 or 0.001 for better solution stepping. And maximum iterations per time steps, you can set it as 0 on reporting interval 1, update profile interval 1, all the remaining are defaults, and just click on the calculate option. Wait until this 100 time steps are performed. You will see the details like this. So it is now running. Let it start. Once it is starting, then you will see the progress of how simulation is going on. So it generally takes time, and because I just gave only 16,000 cells, it won't take much time, but it needs to set up the simulation in your system. If you are running for the first time or very after long time in your simulation, I am running the simulations in my system for after a long time because I don't run my simulations in my laptop. So it takes time for you to begin your simulation. Once it is done, you will see the uh, pressure and velocity distribution different to the one that we are seeing right now. This is the expectation that we gave to the solver. This is how the velocity distribution should be, and this is how the pressure distribution should be. But later on, after a few time instants, it will give the correct or physical phenomena that actually happening in the real world, how the pressure distributes at that particular velocity, and with respect to this diameter of the cylinder with the fluid of water. Okay, so after completion of the cylinder, can someone tell me what will be the time step result that we are going to get? My time step size is 0.001 and my time steps are 100. That means I am now asking my simulation to get the solution for every 0.001 second, and I'm running for 100 time steps. So what will be my final solution time step, time in seconds? Can someone tell me that? I'm moving in steps of 0.001 and running for the 100 steps. So what will be the end time? My question is clear, or shall I repeat again? I am moving. My simulation is now will move at the time step of 0.001 second. Okay. And it will move for 100 time steps. My starting time is 0. Then what will be the final time? Can someone quickly tell me that?
So 0.1 second.
0.1 second. Very good, Sayak. So it will give you the 0.1 second. It is still taking time more than as expected. It's already started. You can see maybe in the background it occupied my memory. You can see my CPU is running at almost 100%. And because I gave only 10 logical process, all the 10 logical process are occupied on only these two. Only these two are running at around say 70 or 60%, because remaining all are occupied with the simulation. For the simulation, only these two are left for looking at the background processes. Okay, so that's why my all these processes are occupied, but it is yet to start. The simulation is yet to start because you can see it is showing nothing here, iterations or continuity or anything. So once it starts, then you will see some kind of progress of the simulations. Okay, so in the meantime, I just allow it to start running it, and it will start soon. So in the meantime, can you all do it in your background? And you can also have any doubts, you can let me know. I will hold here
Sir,
for some time. Yes, who is that? Yes, Aman.
sir, Aman. Sir, I have a problem in my geometry section. I updated all the sections and then try to join the geometry with the mesh section, but here is not showing the green tick, sir. How can I do it, sir?
You can right click and click on update. Is it not available?
Sir, I updated, but still it is showing the question mark, sir.
Okay, can you show me your, can you share your screen? In the meantime, the simulations will be done by that time. Can someone quickly, can you share your screen and show me that?
Yes, sir. Can you see that, sir?
Yes, I can see. So open your geometry now. I see your geometry has a problem.
Yes, sir. The data, sir, I updated the data and generated. Still, after generating, still
Go to the
I
modeling.
cannot.
No, open it. Open, don't close it. Open it. Go to the modeling.
Modeling, sir. Yes, sir.
Yeah, here you see you should have only one surface, but you have generated many surfaces. Delete
Okay,
all
sir.
the unnecessary surfaces and delete all the unnecessary sketches. That creates this kind of problem. If you are not sure what are the
So,
correct sketches and correct surfaces, delete all and redo the geometry.
okay, sir. Uh,
Yeah, this is the correct one.
if
So you
I
can
see,
delete, right click and delete all remaining.
okay, sir.
Yeah.
Uh, delete. Yes. Yes. So,
Everyone, please try this up to these steps on your end. I will share this recordings video also soon. If you have any doubt, you can just share your screen and ask me right now itself so that I can help you with that process, what to do the next.
now it is right, sir.
Yes, now you can generate it and update. Now you can see it is ready for your
Yes,
mesh.
sir. Yes, sir. Yes, sir.
Very
It is
good,
a
Aman.
great picture. After that, sir.
After that, go to the meshing part.
Sir, how can I find the generating measure?
There
It is
is an
not showing,
option. It is not showing. Click on the mesh, right click, generate.
sir. Generate, sir.
Generate it. Right click and generate. Or you can generate it. Okay. Now, wait. Now go to this option. Can you see there is wireframe? How do you change from wireframe to, can you keep your mouse or hover your mouse on the option? How do you change from wireframe to the shaded option?
Wireframe to shaded option.
Yes. Go to the beside option, adjacent one. Beside, right side. Go right. Along this. Go along along the tab. Along that. Yes, along that. Left. Left. You already crossed it. Left. Come left. 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 Yeah. Wait. Right. There is, then at that you can see a option called zoom to fit.
Zoom to fit.
Zoom to fit.
Pan.
Fine.
Zoom is there,
Not
sir.
zoom to fit. Go right. Go to the site.
Yes, sir.
Click
Zoom to
on
fit,
that.
sir.
Yes, click on it.
Yes, sir. Yes, sir.
Okay.
I
Change
got
your
it, sir.
mesh size and create the correct mesh. Let me share my screen once again, Aman. The simulations are just started
Okay,
so
sir.
that you can share your screen once again later. So the simulations are started now. You can see the progress of the simulations. Is it visible, everyone?
Yes, sir.
Yes. So is it visible, everyone? You can see my simulations are just started. And this is the progress of your simulation.
Yes, sir. Yes, sir.
Yeah, okay. So once it is done, now then I can show you the details how the velocity field and pressure field details after 0.1 second, as someone told that it should be 0.1 second because my time step size is 0.001 and doing the 100 time steps. I'm marching for 100 time steps. So 0.001 into 100 is you will get the solution of pressure, velocity, and details. That means flow field details. Flow field is nothing but velocity, pressure details, after 0.1 seconds, and other details also if you are well aware of different things. So my solution is complete. Let's see the details, how it looks like. So if you want to see, if you want to see the pressure field again, it is the same process. Click on this contours and let me delete it for you and you can do it once again. So here, expand this graphics button. There is a graphics button, expand that and double click on the contours. Okay. And don't select anything, uncheck the global range, velocity magnitude and click save and display. You see my velocity is still looking the same. There is no update in my velocity. So let's see whether at least the pressure field has changed or not. कल सुबह से सुबह सुबह आ जाए. So click on the, if you change your pressure, click on the pressure and static pressure. Now save and display. You see my earlier the pressure field is completely blue. If you all remember correctly, how many of you remembered correctly earlier that at time step 0, the pressure field is completely blue? You all remembered it, right? If you remembered it, can you please raise your hand? Only 2. Okay. Fine. So now after 0.1 second, now you can see my pressure field is somewhat changed. It is completely different than what we actually seen to the previous. So it is not yet converged still. It is not the complete solution. It is not the complete solution. Why? Because we are we did with some random mesh. Random mesh in the sense we did not check whether our mesh size is correct or not and whether it is suitable for our mesh or not. So we just use some random um, cell size and we just perform the simulation. So we already know what should be the pattern of at this Reynolds number. The pattern should be, let me show the pattern. Let me draw the pattern for you once again. Okay, so this is your cylinder. You should get a pattern like this. Please correct me if I'm wrong. So this kind of recirculation pattern one should get for this particular Reynolds number of 20. Okay, this kind of recirculation pattern. So we are still not yet reached to this pattern because maybe the time step that we ran is not sufficient, or you see if your graphs is somehow coming like this. Let me show you that. If your simulation graphs are coming like this, it has a steepness. That means it is like saying that your information is not progressing correctly, but it is still has some steepness. So later on time instance, after very long time instance, that means you may need to march for 1,000 time steps or 10,000 time steps. After that such a long period, then you may have a chance to see a correct solution. But still, you need to decrease your cell size. Right now we use the cell size of half of our radius. Okay, further you decrease your cell size, you may get a good solution. Further you decrease your cell size, you may get the good solution at very like the same pattern that we discussed. So like that we need to progress our solution. So this is the first step for you all beginning to see whether at least whether you are able to start your simulation or not. If you are able to start your simulation, and the next step is trial and errors. We need to decrease our cell size, and finally reach one particular cell size so that that is sufficient for to capture the solution as people already described as it is a solution in experimental way. experimental way, everyone already performed this flow over a cylinder and they see in the patterns what I showed you yesterday. So those patterns can simulate it now perfectly with this understanding. Okay, with this kind of simulations. You see this line is decreasing. That means these lines, all these lines, the black and green and red, these lines should come to as low as possible. Right now, this black is at 1e minus 3 and the remaining two are below 1e minus 6. So if these three are coming as low as possible, like say 1e minus 4, 1e minus 5, 1e minus 6, then that means your solution is converged and whatever your solution you got is a very good solution. All right. So right now there won't be any big changes in the solution because the black line is still at 1e minus 3. When you get a very good solution means that if it is any severe changes in these three, the like how like if it is coming constant, then you won't see any different solutions. If it is coming decreasing, if you're seeing any decreasing pattern, then you may see some good solution. Okay, so I hope up to this everyone understood. If not, we can discuss it once again. I will share this video to you all also, so you just follow this pattern, the same contents I gave you that, and we will see the correct settings so that this is for your complete understanding of what are the settings we need to do. These are not the correct settings because we did not choose the correct mesh. We did not choose the correct details of velocity details are correct, but step by step, other details that we need to enter in the Fluent also, I will let you know what are the things to change so that you are getting the correct pattern. But you should have an idea, basic idea of what are these settings, why we are using these settings. If you are interested and really want to simulate on your own, decrease the cell size and try performing with the same steps, you may will really end up with the correct solution of the pattern that we seen yesterday. Right now the pattern is like this. So right now this is the pattern. You are seeing the pattern, whatever this, let me show you the contour lines also. Okay, this is the pattern right now. I hope everyone it is clear for you all. Um, how many of you are able to see this pattern?
Yes, sir.
Is it clear? So this is how the pattern is. If you want to see this pattern, you just click on unfilled and click on the contour lines option there so that you will get this kind of pattern. But this is not what we are looking for. We are looking for something else. Okay. Yeah. Fine. That you can get after doing for a very long time of simulation. It should be very long time, or you may need to decrease the cell size. So that decreasing of the cell size and those kind of things we are going to perform. I will tell you the details what should be the cell size and how long we should run to get the correct pattern. By the time, I request everyone at least to get up to this kind of pattern by using the same settings that I just taught you now. Is that clear, everyone? Or any questions? We have 1 more hour actually. I will just quickly, if you are already note down these steps, you can practice it at your end in this 1 hour. And I will also upload this video right now. If you have any queries, you can ask me now.
Sir, can you
Sir,
show the
Yes. Yes,
sir,
someone
can you
please
show
tell
the
me.
element size again, sir?
Element size, how to set the element size, or what is it? What you want exactly?
What is the element size you said? So, can you show it again, sir?
I set the element size half of the radius.
Okay, sir. Okay, sir.
The element size is half of the radius. Yes, someone else is asking something.
Sir, I was asking like, can you show the results of this results portion?
Results portion.
This, this
Results portion means how to show VM.
convergence, sir, convergence.
Convergence is not yet done. Convergence will take time.
Oh, okay.
Convergence will take time. You need to run for a long period of time, or maybe your mesh is not sufficient to get the correct convergence. or you need to decrease your time step to get. So you see, I can show you in such a way that if you want to get a very good convergence, you may need to decrease your time step size. Sometimes the time steps is also not sufficient. You see, there is a server license problem. So any more question? Any more queries? I will show you the convergence. It is not yet converged. Convergence details also I will explain them. I already told you convergence means you should get a values of there's those three colors like black and whatever the colors that you are showing in the graph that you're seeing in the graph. Those should be below the 1e minus or 10e minus 4 or 1e minus 5 like that. That we say as a convergence. Why we are seeing it as convergence, we will see one by one in details. What is this? Just give me a second. Any more queries? Okay, if no queries, you can, I will just send the video. Everyone will follow it up, right? Or any step it is seems difficult for you. Just raise your hand if you find any step is difficult for you to understand or why we are doing that. Yes, Arhit.
Sir, I had a question like this. I didn't get this hybrid initialization and standard initialization. What is the difference between those two?
Hybrid initialization has a initial capability. It will give you the reasonable solution at the initialization itself. Like suppose if you're solving of any partial differential equation, if you are not starting with the correct initial guess, or if you are starting with a very far guess to the solution. Let me say, the partial differential equation solution should be based upon your conditions. The solution should be 5 output. Let's say as 5 units. If you are giving the initial solution as 10,000, 5 is very far from the 10,000. That means the partial differential solution or the numerical scheme tries to approach your solution 5. If you are giving very far solution, that is 10,000 as initial solution, initial guess, it takes very long time to approach your answer 5. But if you give somewhere approximately the near solution, say 7 or 8 or 10, that means it can easily converge to your solution 5 because you already know that approximate solution will be around 10, but the current solution is 5. So it approaches to your correct solution easily. So that is the difference between standard solution and hybrid solution. For the standard solution, it always gives you, it always applies the initial solution as 0 at everywhere. A 0 or 0 gauge pressure or 0 pressure, 0 velocity, everywhere in the domain. But hybrid gets some correct value based upon some iteration. It gets some correct or approximately near values to the solution and applies those solution to each in the domain, in the computational domain. Did you understand?
Yes, sir.
See, there is some problem with my licenses here. Not able to open the Fluent. Okay, anyway, any more questions? Okay, Mohammed. If no questions, so let me upload this my Fluent server as a problem. I will try to check these things, what happening here. Maybe if you are having a student version, you can easily, you don't find these kind of server error issues. I have some license issues happening here. We'll find it out and we'll let you know. So everyone try to follow the same video and post your queries in WhatsApp. I can try to reply maybe in the next class or at the moment itself. If your question is small and whether if I can explain, I can explain that at the time instead. So please follow up the video that I'm the same thing I will post in YouTube, and complete the process up to the simulation part. And the next session, we will see what are the fine tuning of these simulations. That means we are yet to fine tune the things that we just created. This is all like a structure we created. Now we need to patch up with cement, and we need to complete with the colors. We need to paint it, and then we need to give your furniture, everything to create building, like if you consider it like a building a home. Okay, fine. So if any more queries, you can quickly ask me that, and then we can discuss. I mean, if you are there in the lab, you can practice it. I will send the video now itself, and you can follow up the. You can open the answers print and you can try at your end. Any more queries quickly? No more queries?
No, sir.
Okay. If no more queries, we'll see you in the next session. Thank you all for joining. I hope